Okay, 7.4 is all about approximating the square roots. So we are going to do some vocab first. Take a minute and pause this and write down your vocab words. A rational number is basically all of the numbers that you have dealt with in middle school. An integer is just a negative or positive number. It's what's on the number line. A whole number is what you started counting with when you started with 0. And the natural numbers is what you really start counting with when you're a little kid. You start 1, 2, 3. Those are natural numbers. Irrational is everything that is not a decimal or a fraction. So basically, if you have a number like pi, a number that the decimal doesn't end, the decimal doesn't repeat, it's never going to stop, that is going to be your irrational number. Okay, so we've got this broken down, and I'm sure you've seen this before, where we've broken down the rational and irrational numbers into what we have. And so there's two different categories. We have rational and irrational, and then inside of rational, we have integers, whole numbers, natural numbers. Everything that we deal with is a real number. All of our numbers are real. We do not do imaginary numbers until you get to high school, way on in high school. So this has to classify all of them. So I have the square root of negative 12. Well, I don't know that that's a perfect square. So what I do know is that it's actually going to be an irrational number. That is the most specific classification. It's the only one it falls into. Then I have the negative 0.25 repeated. Well, it is a decimal, which means it can be written as a fraction because it ends or repeats. So since it can be written as a fraction, it's only under rational. Then I have the square root of negative 9. Since the negative is on the outside of the square root, I know that that's okay. It's a negative 3. So since it's a negative 3, it actually is a rational number and an integer. The most specific is going to be the integer. All right, next number is 72 divided by 4. Well, if I take 72 divided by 4, that's going to give me 18. Well, 18 actually fits into all those categories. So it's rational, it's an integer, it's a whole number, it's a natural number, it's all of those things, but the most specific is the smallest circle up here, which is going to be a natural number. And finally, pi, we talked about earlier, is a decimal that doesn't end and doesn't repeat, so that one has to be irrational. Okay, so when we talk about approximating square roots, so we're not really using a calculator, so we have to try to figure out what is going to be the square root when I don't know the perfect square. So you need to find two perfect squares that kind of fall between and then figure out which is closer. So if I have the square root of 8, okay, so the two numbers that I know fall between that are 9 and 4. Those are two perfect squares that fall between. So I have to decide, is my 8 closer to 9 or closer to 4? Well, I know that it truly is, get a pen up here, it actually is going to be closer to the 9, which the square root of 9 is 3. Okay? So then I go to the next one, and I say the square root of 13. Well, my perfect squares that it falls between are 16 and 9. They are both negative. Is that 13 going to be closer to my 16, or is it going to be closer to my 9? Well, it's going to be closer to 16 because it's only 3 away, where with 9, it's actually 4 away. So the square root of 16 is going to give me a negative 4. All right, so 24. Take a second and think what you can do for this one. All right, so what we're doing here is I'm going to have 25 and 16. So it's a number above and a number below that are perfect squares. So since I have 25 and I have 16, 25 is going to be closer. The square root, and then notice it's a negative, the square root of 25 is 5, so it's close to a negative 5. And then finally for 110, I've got 121 and I have 100. Now this one's 11 away. This one's only 10 away, so they're close. But it's actually going to be closer to 100, which the square root of 100 is 10. Now, yep, I could grab a calculator and I could say the square root of 8. And actually, I'm going to do that right now. I'm going to find a calculator and I'm going to do the square root of 8. And that is going to give me 2.82. Is that close to 3? It absolutely is. So I know that I'm accurate in that guessing. So now that I can approximate, I have to decide which one's greater. So if I have 4 and 1/5, that I know is a decimal of 4.2 because it's 4 and 2/10, which is the same thing as 4 and 2/10. Okay, so then I've got the square root of 23. Well, is that going to be closer to 25 or to 16? It's going to be closer to 25. And the square root of 25 is 5. So since that's 5, what I can do here is I then decide which number is greater. Well, it's easy for me to decide what's going to be bigger, 4.2 or 4 point close to 5, because it's why it's not 25, it's close to 25, so it's probably going to be like 4 point, I'd say 8, close to it or so. And so this is going to be my larger number. All right, so the next two. So they're both square roots. 10, I have to go between 9 and 16, and then 5, I have to go between 4 and 9. Well, 5 is going to be an easy one because that's going to be a negative 4. Oh, and look, I don't even need to go any farther than that. It's a negative. Guess what? That means that the positive number is going to be greater. Done. Okay, finally I've got these two. Now, I think this one's really interesting because you have to think logically about this. I've got the square root of 2, or the negative square root of 2, and a negative 2. Well, the negative square root is going to be like negative 1 point something, right? And then negative 2. So on a number line, you have to think which number is bigger, which number is farther to the right. Now that I can decide that my number farther to the right is this, it's actually going to be the number closer to 0 since it's negative, and it's going to be that negative square root of 2. Okay, so your notes are a little wonky, but this is what it should look like. So order the numbers from least to greatest. So with 38, what I did here is I said, okay, what am I close to? I've got the square root of 36. I could do that. I could do the square root of, what, 49? No, we're going to do the square root of 36. So it's going to be close to 6. I estimated about 6.1. With the second one, I actually took 100 divided by 3, which I know is 33.3. Okay, now, if we're talking square roots, that is less than 36. 36 is kind of my window I'm going here, because the square root of 36 is 6. So this one is going to be a little bit larger. This one's going to be a little bit smaller. So that's going to be roughly 5.9. And then this one is not even a square root. It's 6.5. So my one that I have first is going to be, let's get a pen here, the least to greatest. So my smallest number is actually going to be my square root of 100 over 3. That's first. And remember, you always want to write it back in the form that it came in. All right, next I have either 6.5 or 6.1-ish. I don't know exactly what that is, but it's got to be close. So smallest to greatest, that's going to be the square root of 38. And finally, 6.5. Now remember, you're not going to have a calculator, so you're going to have to be working on estimating these. Okay. So story problems, this is the real stuff. So the distance in nautical miles, you can see with a periscope, is 1.7 times the square root of h. H is the height of the periscope above the water. So they have marked it here for us that this is the height. Can you see twice as far with a periscope that's 6 feet above water than one that's 3 feet? So if this whole thing is 6, can you see twice as far if it's only 3 feet? Which you think logically, okay, well 3 feet is half of 6 feet, so maybe you could see twice as far. Okay, well let's actually plug it in. So what I need to do is I need to plug in my 6 and my 3. And so that you have the equation. Now, what I know is that the square root of 6 is somewhere between somewhere between 2, because the square root of 4, so I've got 4 and 9. So it's somewhere in between 2 and 3, okay? Which would mean this is just less than 4, because I've got 1 or 4. It's closer to 4. So they're actually both pretty close to right around 4. So I'm going to assume right away that no, you can't. But what I actually did for you is I plugged it into a calculator. And if I actually take 1.6, or the square root of 6 times 1.17, I get 2.865. And if I take 1.17 times the square root of 3, I get 2.026. This is not doubled. It's not even close. Yeah, it's a little bit bigger, but it's not even close. So in order to explain that, you can say that there's no way that it can be doubled because the square roots are doubled. Now, if the square roots were doubled, if they were talking 3, no, what if we said 4? And so that the square root of 4 is 2, and then we said here it was 16. So then the square root of 16 would be 4. Now that would be doubled, but that's a whole different ballgame.